recording. I'm gonna present. You're gonna wait. And three, two, one.
This is Project Cybertruck by Team Overkill. Team members consist of Papa, Andrew, myself, and Jack.
And so for this project, we were able to make a Pi control RC car and improved over the design relative to the previous presentation. We were also able to build a website to control the car and monitor its behavior. We were finally able to do some of the video streaming for the Raspberry Pi. We were able to add the live video stream to the website. We also added some distance sensor to the Pi for collision avoidance and distance tracking. Added an emergency braking system to avoid some collisions. Some of the logic to stabilize the car while it was driving, and also the logic to traverse the um, down the hallways have been added, and finally a maze logic to choose the next path and traverse it at the end of the hallway. So here we can see basically how the car is actually wired up. We have three sensors, one in the front, two on the sides, and also we have a Pi camera on top of the car. Some feature picture, we're gonna show some picture of it in a bit. We also have our 6 AA's battery that delivers 9 volts, and also have the Raspberry Pi powered by the power bank, and all of it is also connected. The motor is connected through the L298 and motor controller.
And here you can see the wiring for the three sensors and how they need resistors to reduce the flow to not damage the pins on the Pi. Then here is the wiring for the motor controller driver. And that controls the car turning and driving.
And then here is the overall structure of the web app. So on top, as a parent, we have the dashboard that contains the welcome page and the nav bar, and those branch down into the home page, which just gives a brief description about the project. And then the authentication, which you must log into before you can access the controller page, which allows you to remotely control the RC. And then moving on, we have the live stream page, which displays the live stream, and then a QR page, which allows scanning of the QR code to access the site on mobile.
So here on this class diagram at the top, we have our streaming service on the Pi side. It uses the remoted. It also has a list services, connector service, and then terminate connection. So here on the connector service, it provides a link to the database. The website then grabs that link, and then we have our car controller and our stream. And then next we have our database controller. So whenever the website tells it to do something, the database controller will pick it up. The car will then perform that action. Next we have our smart driver, which is composed of sensor controller, maze solver, stabilizer 1, 2, 3, and 4.
So my progress for the project was I incorporated the live streaming on the website with YouTube and MJPEG. I updated the website with the homepage and added a QR code, created the navigation for the website, and then I formatted the website so that the styling would be dynamic and it would be mobile friendly. And then I discussed the logic and implementation of the car's obstacle detection and driving method.
And for my project, I was in charge of the video streaming most of the time, and so I was able to get the Pi set up for such. I was able to install the FFmpeg software and added the LibX 264 codec for it. I was modifying some of the code in order to have a clear, smooth stream, but due to the latency, I was actually forced to try to learn a few more things. So I went ahead and installed a Netcat and Homebrew on the Pi in order to be able to stream the video directly into um, the targeted machine in order to reduce the latency. But even so, unfortunately, the latency was still a little bit too big. I worked with Andrew on displaying the video stream on the website, however, and I was also able to discuss the logic of the car collision detection and turn decision making.
So what I've primarily focused on is working on the distance sensors to keep the car stabilized while driving down the hallway. Also, I worked on the maze solver class. This activates when a collision is detected in front of the vehicle. Also, I worked on the software diagram for the car code. I made a prototype with basically all the components I had at home, and then I discussed the logic of the maze solver with the team members.
And I had the RC car. I bought it, hooked it up, removed the driver controller that came with it, um, replaced that, and then I wrote the initial code to control that, and then I hooked up all the sensors, the camera, and then I worked with the team members for some of the logic of how things should react, and as the car is driving, and how to avoid collisions, how to stabilize the car while it's going down the hallway. And then I also added in um, the code to work with the remote IT service to enable the video streaming, to open that port and start the streaming service. And I believe that's it for my part. And then here you can see the progress over time, from buying the car to removing the motor controller to testing the resistance, the voltage, everything. And then opening, or basically gutting it and replacing everything, putting everything in there.
And here we can see the final result with all of the different components attached. We can see there are the sensors right here in the front and on the side, and we have also the camera right here. Jack did a really good job putting everything and make it looks quite impressive, to be honest.